And if your data open and close the braces, you would be able to see all the packages, or sorry, all the data sets which are there on your computer now as part of installing the packages. So whenever you install packages, there will be a few default data sets which will get installed on your computer. Right, so let me run this data. So data sets is a package which holds all of these different data sets. The way I see the number of data sets that we have which are inbuilt within R covers all the industries, all the sectors, and all the domains which we might have never heard about. From that perspective, if you want to practice on your industry, your sector, your domain related projects, your domain related data sets, everything would be available on R. The only thing is you just need to do internet search, web search, and then try to find out which data set would be relevant for your purpose. All right. And say you want to refer to stock market. Say you're from FSI, Financial Services Insurance Industry, and say you're dealing with the stock market data. You want to forecast what will be the stock market value tomorrow, so on and so forth. Then you can use probably these kind of data sets. Here we have EU, European Union stock markets. How do you know this data set name? You need to do some research on internet and then you'll find out. Data of this would load this data set here. If you want to view the data set, you say view and you have DAX. DAX is German based, stock market. SMI is Switzerland. CAC is France. FTSE is UK, right? But since I've used this data set in the past, I'm able to say that if you're new to this data set, you just do a question mark, EU stock markets, and you'll get to see that. So here you have daily closing price indices of major European stock markets. Right? You have the data pertaining to Germany, that's DAX, Switzerland, France, UK. And you have the data which is sampled in business time, that is weekends and holidays are omitted. And it says it is MTS. I'm assuming that this is multivariate time series. When you say multivariate, you have multiple entries, columns there, and you have 1860 such entries. There is a data set called victims. So even before that, let me remove these data sets using the broomstick function here. I've loaded this particular victims.txt file using read lines. Now if I call this object called victims, you see there, you have percentage, data on the Titanic victims. This is the first record, the second record, third, fourth, so on and so forth. And you have percentage, names, births, and death here. It's in a very clumsy format. We need to bring this unstructured data into structured format. What do we do for that? Right. First of all, I'm trying to create this as a data frame because you have numerical and non-numerical values. You want to hold this in a data frame in a nice structured format. So I'm assigning this to df, an object called df. And if I call df, there we go. It's in a neat structured format. But we want to, yes, of course, get rid of this percentage. We want name to be in the first column. We want the birth date to be in the second column and the death date to be in the third column. 1912. Everyone has the same death column. This goes to say that in the year 1912, all of these people died. And this is the data pertaining to Titanic. So the Titanic ship sank in 1912. Right? And NA is probably the bodies were not found, so you cannot determine that they died with certainty. All right. If you look into class of DF, it says that it's a data frame. If you look at the length of DF, it says that it's 1 because it's considering entire thing as one lot. The number of rows would be 11, but the number of columns here should be 3, right? Anthony name, birth date and death date, but it will say that number of columns equal to 1 because it has combined all of these. If you look at the dimensions, it should be rows multiplied by columns. So you have 11 rows multiplied by 1 column. 11 by 1 is the dimension. If you look at the structure, it says that this is a data frame. It has 11 observations and 1 variable, 11 rows and 1 column there. And it has a factor with 11 levels. So it's assuming that this is a factor and these are the various levels within that, which is wrong. These are all different fields, etc. Now, we need to use a few data manipulation functions within R to make this data structured. Our end objective is to have 3 columns with column name for the first column should be name, second column should have a column name birth date, and the third column should have the column name death date. So here we have grepl, which is a function, and you're saying caret percentage. So wherever you find a percentage in this victims data set, you want to record that and store it in comments, and that's going to give you a Boolean result. When I say Boolean, in the first row you have a percentage, so it will say true. We do not have a percentage in the second row or third or fourth or in all of these, so it will be false. And in the last row it would say true. So let me run this. There we go. True, false, 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 true. And you can probably store everywhere where you do not have those comments, not comments, right? You want to store it in victims. That is, wherever you have these percentages, you want to just get rid of that. And you have assigned it to text. This is one way of dealing with the data. All right. Or, yeah, there's the same thing, grepl. Oh, so let me remove this, is not required at all. Now, there is another function called grep. This would also try to search your victims data set, try to find out wherever there is a percentage value, and you will assign the output to this, but you would get the column name, the row name. So you have this percentage in row 1 and row 11, so it has to give you row 1 and row 11 there. Let me run this in this. There we go. Row 1 and row 11, both of these rows have percentage. That is exactly what this is trying to tell us. And if you do, this is not basically. Not. You want everything except for these two, 1 and 11, and you want to assign it to an object called TextScript. So on victims data set, I do not want this. And what does this hold? Comments underscore grep, it holds 1 and 11. So if you run this, it will have rest of the values basically. Right? It's saying number of characters is 0, of course. You do not have any characters there. But if I do text of 1, here you have text, right? So if you do that text of 1, it will give me the first row, Anthony 1870 1912. Because here what did we do? In the comments, you told everything which doesn't have these two true values, assign it to text. So it has assigned the second row, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. All these rows to this object called text. And if you want to refer to text of 1, it will refer to this false, first false. That is Anthony 1870 and 1912. And you can assign that to an object called X. Now if I just run X, you will have Anthony 1870 and 1912. Here, let us discuss about two more functions called sub and gsub. The function sub has this pattern, a replacement in X. What does that mean? It is going to look at the pattern, that is, you want to look at the digit and replace that with blank space on what? On X. X holds what? Anthony 1870, 1912. Right, so if I run this, and we are assigning the output to an object called Y. Let me run this. And if you look at Y, the sub function would try to find the first digit, replace it with a blank space, and then stop. And then return the rest of the values as is. So if you look at Y, Anthony, in the first digit was replaced by a blank space. Now if I show text of 1, it still has the same thing, Anthony and this. If I want to replace all these digits with a blank space, then sub function would not work because it's trying to search, find the first digit, and then replace the first digit with a blank space. Right, so I'm once again assigning text of 1 to object X. And if you do this, use this function called gsub, it is going to find all the digits and replace all the digits with a blank space on this X, which holds Anthony 1870, 1912. So let me run this. And if I call Y, look at that. Now all these digits 1, 8, 7, 0, 1, 9, 1, 2, all these numbers, digits, are replaced by a blank space. Alright, now let me take another value. Text of 9, you're referring to the 9th entry, which is Percy here. This is Percy 1910, 1912. You can also use a function called reg expression. And you're saying 9, comma, text of 9. What would this do? Let me run this and show you. This would tell that the number 9 is appearing in 8th position. 1, 2, 3, 4, 5, 6, 7, 8. 8th position has this number 9 and it's a single match, and yes, you found a match, so it's true, a Boolean output there. What if you want to see the entire probably entry and then find out all the positions where you have the number 9? Then you have to use the function reg expression, right? And you're saying that, hey, try to locate wherever we have 9, the positions of that, and give me as an output. So I'm trying to assign this to an object called R, and if I call R, you're seeing this. 8th entry here has 9, and the 13th entry also has 9. So if you count here, 1, 2, 3, 4, 5, 6, 7, 8. 8th entry has 9, 10, 11, 12, 13. 13th entry also has a 9. So you have 2 matches and there is a match true. Alright. So this is how you can try to make, some kind of manipulations in your data. If you look at text, basically, you have all these entries. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 entries. And all these are appearing as if they are, some kind of a string data. So if you want to split that string, this text holds all these values. If you want to split it using comma, then you use this function. We are trying to split the strings using comma. So Anthony will be separate 1870 would be separate and 1912 would be separate. So you're trying to separate them using comma. And let me split those and assign it to split lines. Now if you call split lines, look at that. So Anthony is a different entity now, birth year is a different entity, and the death year is a different entity altogether. But this format we have already discussed. This is in a list format, which is not probably in a neat structured format. Hence, you can create a matrix by unlisting this, split line. So it's a list now. Unlist would unlist that, and you're creating a matrix. And you're saying number of rows. We have seen this function. Matrix, number of rows equal to some value, and then by row equal to true. Number of columns equal to something, by row equal to false. We have tried all these things. So now, number of rows is equal to length of this. So length of the split lines. How many? We have 1, 2, 3, 4, 5, 6, 7, 9. 9 would be the number of rows, and you want to arrange them by rows. So if I run this and store the output in lines and call this lines here, you have this, right? It's in a matrix format. But one more thing which is missing from here is the column names. You do not have the column names here. This is the name, this is the birth year, and the third column is the death year. So we are coming up with the column names for lines, and you're saying assign name, birth year, and death year. So let me run this. What happened? Sorry. Here we go. Now we are trying to create a data frame. Remember, data frame is a nice tabular structure which appears, with proper column names, with proper segregation and all that. So we are creating a data frame on the lines, and I'm saying strings as factor is false. So don't worry too much about that now, because I'll show that. So now if you call Titanic victims, the object, if you look at this object, Titanic victims, it's in a neat tabular format now with 9 observations, 3 variables. Here you have, it's in a neat fashion now. So what did we do? We have taken the data which is in complete unstructured format here, and we have given it such a wonderful structure. Of course, we have, over the course of bringing this unstructured data into structured format, we have used a lot of functions for data manipulation, data cleansing, and thankfully we have got a very good data set here. Now if you do a question mark of as.data.frame, and look at this argument called string as factors. Logical. Should the character vector be converted to a factor or not? So here we do not want to probably convert these into factors. Hence we are saying, where did that go? Hence we are saying string as factors is equal to false. Simple. All right. Now if you look at the class of the birth year, this has to be a numerical value, right, basically. So let me run this. It says these are characters, 1870, etc. These are characters. But in reality, these are numbers. So how do you convert this into numbers? Using a function called as.numeric. So you're forcibly converting here something into a data frame using as.data.frame. Here you're forcibly converting something into numeric value, and this is called as coercion. Coercion is forcibly converting a specific data type into another. So here, Titanic victims, $birth year, so you're referring to Titanic victims, the birth year column, and you're converting this to a numeric data. and assigning it to birth year. So let me run this. And if you call this, you get all the values here, right? And now we can also transform it. So wherever you have birth year, I'm converting that to numeric. Wherever we have death year, I'm converting that into numeric on Titanic_victims. So rather than doing it for each column, you can do it at one go. So let me add this and this. If you look at the class, it is numeric. This is also numeric. And here you have the data set. If you look at the structure, it says name is character, birth year and death year are both numeric values. And now you can start taking the average. Average of the birth year happens to be 1882, right? You can also round it off. When you say round it off, it's going to remove the decimals and round it off. It is 1883 because if after decimals you have a value which is greater than 5, it is going to round it off to the higher value. This is something which we all are pretty much aware of. All right.